Good morning, children. I'll remove my mask so that it will be more clear. But please maintain social distancing, hand wash, and wear mask in public places. Today we'll study about the characteristic of periodic of long form of periodic table. What are the characteristics of the present long form of periodic table? As I mentioned earlier, we know that this we can broadly classify into different blocks. The first one is an S block. This 1 and 2 is S block. S block and P block. P is from 13 to 18. 1 and 2 is S block. P is from 13, 14, 15, 16, 17, and 18. This is P block. And we have one more D block here, but this we will not study. And last one, F block here, lanthanides and actinides will be here. Therefore, we will study only the first block and the second block. What are the first block and second block? Yes, the first block is S block, and the second block is P. We will study these two. D and F we will not study in this class. First of all, S block is group 1 and group 2, and P block is group 13 to 18 here. I hope that it's clear. We have this group. We'll study about group 1, group 2, 13, 14, 15, 16, 17, and 18. What happened to the group? Since you are not going to study, I will just drop this one. I use for another purpose here. The first thing is that the characteristic of period in long period table. As we move from left to right, what happens to the elements here? The first thing we will study. As we move from left to right, from your left to right, the first is here number 1, 2, 13, 14, 15, 16, 17, and 18. As we move from left to right, the first thing we have to know is that the valence electron of an element. Okay, what is valence electron? We have to know first. Valence electron means the electron in the outermost shell. Once again, valence electron means the electron in the outermost shell. What happened to the valence electron here? We'll see. As we move from left to right, the valence electron, the number of valence electron, it increased from 1 to 8. Once again, number of valence electron, it increased here. The valence, this first group will have 1 valence electron. All the first group, H, hydrogen, lithium, sodium, potassium, all these will have only 1 valence electron. And this group 2 will have only 2 valence electron. And group 13 will have only 3 valence electron. Group 14 will have only 4 valence electron. Group 15 will have only 5 valence electron. Group 16 will have only 6 valence electron. Group 17 will have only 7 valence electron, and group 18 will have 8 valence electron. Once again, as we move from left to right, the valence electron increases from 1 to 8. 1 to 8 means all this group will have only 1 valence electron. And beryllium, magnesium, calcium will have 2 valence electron, all this including this radium. And number 13, group number 13, Bal, boron, aluminium, all these will have valence electron 3. And 14, carbon and silicon, all these will have valence electron 4. And 15, nitrogen, phosphorus, all these will have 5 valence electron. And group 16, oxygen, all these will have 6 valence electron. And 17, group fluorine, chlorine, and bromine, iodine, they'll have here 7 valence electron. And group 18, helium, neon, argon, krypton, xenon, radium, all these will have 8 valence electron. I hope it's clear. As we move from here, the valence electron increase. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. As we move from left to right, the valence electron increase from 1 to 8. And number 2. Number 1 is valence electron increases from 1 to 8. I hope that is clear. And number 2, the valency on moving from left to right. We have here 2 sub A and B here. Moving left to right, valency. We have 1 and 2. 1 is with respect to hydrogen. And number 2 is with respect to oxygen. Hydrogen and oxygen here. With respect to hydrogen and oxygen. With respect to hydrogen, first we will discuss. With respect to hydrogen, it increased from 1 to 4 and 4 back to 1. That means with respect to hydrogen, it increased from 1 to 4 and back to 1. Let me explain this first. The valency is increased from 1, 2, 3, 4. 3, 2, 1, 0. Once again, with respect to hydrogen, the valency increased from 1 to 4, back to 1. Here, 1, 2, the valency, all this group will have 1 valency, and this group will have 2 valency, and this group will have 3 valency, and this group will have 4 valency, and this group will have 3 valency, and this group will have 2 valency, and this group will have 1 valency, and this will be 0 valency. I will explain later on this. And the second one, with respect to oxygen. With respect to oxygen, what happened here? With respect to oxygen, the valency increased 1, 2, 3, 4, 5, 6, 7. It will increase 1, 2, 7. That means with respect to hydrogen, it increased 1 to 4 and 4 back to 1. 1, 2, 4 and 1. With respect to hydrogen. But with respect to oxygen, 1, it will increase to 7. I hope that's clear. Once again, regarding valency, the valency as we move from left to right. As we move from left to right, the valency, number 1, with respect to hydrogen. Yes, with hydrogen, 1, 2, 3, 4, 3, 2, 1. And with respect to oxygen, 1, 2, 3, 4, 5, 6, 7. That means with respect to hydrogen, oxygen, it increased till 7. With respect to hydrogen, it will increase from 1 to 4 and back to 1. Once again, with respect to hydrogen, 1 to 4, back to 1. With respect to oxygen, 1 to 7, directly oxygen is increased. That means, once again, this with respect to oxygen valency, this will be 7. This will be valency with respect to oxygen, 6. With respect to oxygen, this will have 5. This will have 4, 3, 2, 1. That means all this will have with respect to oxygen, 1 valency. With respect to oxygen, 2 valency. With respect to oxygen, 3 valency. With respect to oxygen, 4 valency. With respect to oxygen, 5 valency. With respect to oxygen, 6 valency. With respect to oxygen, 7 valency. Once again, with respect to hydrogen, this will have 1 valency group, 2 valency group. With respect to hydrogen, 3 valency group. With respect to hydrogen, 4 valency group. With respect to hydrogen, 5 here 3 with respect to hydrogen 2 with respect to hydrogen 1. That means it increased from 1 to 4 back to 1. I hope that it's clear. And we will proceed with the third one, that is the size, that is volume of an atom. What happened to the size? When you speak about the size, first thing we have to know is that the size is measured in diameter. We already know what is diameter. In the circle, we know that in mathematics, diameter is circumference to circumference passing through the center. And here we have the radius here. We will check with the radius. The size of atom is indicated in radius of an atom. It is measured in picometer. The atomic radius decreases as one moves from left to right in period. That means here the size of the radius will here decrease. It will become smaller and smaller here. That means the first group will have this, the radius, they have biggest radius. This is the radius. And as we move here, the radius becomes smaller and smaller till 17. First we learn, and this group I will explain later. And as we move from left to right like this, then the radius becomes smaller and smaller. That means the size of atom is decreasing. I hope that's clear. Size of atom is decreasing as we move from left to right. That means the radius is becoming smaller and smaller and like this. Here hydrogen group, this is the first group, will have biggest radius, and the second a little bit smaller, and third like this will become smaller and smaller as we move from left to right. I hope that it's clear. And here regarding this metallic and non-metallic character, about the size, number 1, number 2 and number 3, size decrease. Then number 4, what happened to the metallic character of an element? Here on moving from left to right in a given period, the metallic character decrease gradually. On moving from left to right in a given period, the metallic character of an element decrease gradually. That means as we move here, metallic character it decreases like this. As we move from left to right, the metallic character decreases. Metallic character means electropositiveness. Here, this, like let's take an example like this. This metal, it become like as we move from here, it changes slowly, and after it will be metalloid. That means in between metal and non-metal, and after that it will become non-metal. And the metallic character here, it will be less and less and less. And in this group here, as I saw it here in this, if you check carefully, this group electropositive character is very strong here. Electropositive character decrease little bit. Here it decrease here. As we move here, it decrease and decrease. Like for example here aluminium, and we here silicon. This silicon is half metal, half non-metal, and that's what we call metalloids. And after that, this non-metal will start here. The non-metallic character also is increasing. As we move from left to right, non-metallic character is increasing, and metallic character is decreasing. And after that, reactivity. Gradually, as one moves from left to right in a period, the reactivity of an element first gradually decreases and then gradually increases. Reactivity number 5. As we move from left to right, the reactivity gradually decreases. That means the reactivity will slowly come down like this, and after that it increases again. The reactivity slowly is coming down and increases again. That is, from that what we can understand is this. This first group 1, they are very, very reactive metal. We know that these are metals and this part are non-metal. These are very, very reactive metal and little bit less reactive, and after that here it will become more and more reactive. The most reactive is 17 again here. 17 is the most reactive non-metal group. Metal group, the first group, it's most reactive, and the second group most reactive here. Second group means non-metallic group. The reactivity, it go down like this, and after that it increase. That means these two are the most reactive metals and non-metal. Most reactive metal, most reactive non-metal, less reactive like this, less reactive like this, it will come down. I hope that it's clear. Then we will proceed to the sixth part, that is nature of oxide of element. As one move from left to right in a period, the basic nature of its oxide gradually decreases, and acidic nature oxide gradually increases. Like same what we have here, it gradually decreases and increases. Same thing, the nature of oxide. As we move from left to right in a period, the basic nature of oxide gradually here. These are metals are basic and non-metal are basic. Let's say like this to make you understand. The basic nature is decreasing like this, and acidic nature is increasing as we move from left to right. As we move from left to right, the basic nature is here the highest, and the acidic nature is here highest here. Therefore, as we move from here, it gradually decreases the basic nature, and acidic nature is increased. Okay, any question, any query, please feel free to ask me. Thank you.